In this video, I'm going to give the correct solution to the third question from my last video. The third question for Routh-Hurwitz Criterion. I'll display the question on my screen. S to the power 5 plus S to the power 4 plus 3s cubed plus 3s squared plus 15s plus 10 equal to 0. So now the solution, the Routh array for the system for this particular system is we have, since the highest power is 5, so start from s to the power 5, s to the power 4, s3, s squared, s, and s to the power 0. So from here we'll take the coefficient of the first, skip the second, take for the third, skip the fourth, and this is 15, and then the second one is 1, 3, and 10. So now, from my previous video, I already explained how the operation goes. This will be 1 times 3, 1 times 3 minus 1 times 3 divided by 1. This will give you 0. The next will be 1 times 15 minus 1 times 10, all divided by 1. This will give you 5. So now, note this, because we cannot continue this array with 0. As long as the first column has 0 and the operation is not complete, there are two methods that can be used to complete the array. Is either you use epsilon method or auxiliary method. Epsilon is used when only the first column, 0, appears only in the first column while others are not 0. But if 0 appears in the entire row, then you use auxiliary method, which I used to solve other questions in my previous video. So we can continue. What we are going to do in order to complete this, we are going to make epsilon equal to 0, or 0 equal to epsilon, anyone, in order to complete the table using epsilon method, since only the first column has 0. So drawing out the table again, or let me just start from s cubed substitute epsilon in place of 0 and 5 and then 0. If you complete the operation, that the last value should be 0. S squared. Now this will be, let me add this other row because we will need it for this operation. If you do the same thing here, this times this, this times this minus this times this, all divided by this, you should have this 3 times epsilon, or let me do it this way, this will be 3 minus 5 over epsilon. After simplifying, this is what you have. This 3 times epsilon minus 5 times 1 divided by epsilon gives you this. And then for the next column, you have 10. And this will be 0. Then for s to power 1, you have 15 epsilon minus 25, the same pattern. Sorry, this is entering the second. And then this will be 0 and 0. For the last row, this will be 10, 0 and 0. So after you have done everything, you can now substitute 0 in place of epsilon. Substituting 0 in place of epsilon, the table becomes for a system to be stable, all the coefficients of s must be present and positive, and there must be no sign change in the first column of the Routh array. So now the first condition has been met. I explained it in my previous video. The first condition has been met, which is all coefficients of s must be present and positive. Now we are checking for the first column if there is no sign change. So this is s squared, this. So substituting 0 in place of epsilon, you have 0, 5 and 0. Then this will be 3 minus infinity, 5 over anything over 0 or anything divided by 0 is infinity. 10 and 0. This will be 5, 10, 0, 0, 0 and 0. So now we can see that from here 3 minus infinity will give you a negative value, because infinity is a very large number, very large number. So there will definitely be a sign change in the first column from s squared row s squared first column. So this shows that the system is actually unstable and the roots of the equation lies in the right half s plane. Thank you for watching this video, and don't forget to like and subscribe to this channel for more videos like this.